You can say a body accelerated uniformly from rest at a rate of 8 meters per second squared for 10 seconds to attain a velocity v. Attain velocity v. It then maintained maintained the velocity for 8 seconds, and finally decelerated at a rate of 6 meters per second. And then part A, sketch the velocity time graph. And then part B, find the maximum velocity attained. And then part Roman 2 could be the total distance covered. Total distance for the whole journey.
That is it. That is our good example. That supposing we are having a body which is going to begin at rest, it will begin by increasing its speed steadily at a rate of 8 meters per second. That speed will be increased for 10 seconds. Is that okay? And then after attaining some speed, it maintained the speed. If it maintained the speed for 8 seconds, is that okay? It maintained the speed or the velocity for 8 seconds and then finally decelerated. Now, the question is, can you sketch the velocity time graph? How do we sketch the velocity time graph? This is what we do.
This is velocity in meters per second. This is the time in second. If the body started from rest, that means our graph will begin here. If they give you acceleration, that acceleration is always a slope. You'll draw a line slanting. If the acceleration is, if it is accelerating, that means that velocity time graph for accelerating is, we looked at it behind there, that if a body is accelerating, velocity on the velocity time graph, we draw a line, a line with a positive gradient. We looked at that. Velocity time graph for a body which is accelerating is a line. If it is accelerating from origin, the line begins at origin and draw it with a positive gradient. And now this body, after reaching that point, it had a velocity v. And it had done this, the time was 10. And the acceleration here, the slope was 8. Then they're saying that it maintained the velocity for 8. After getting this velocity, it said I'm going to move with it constantly. For how long? For 8. That means there should be now 18. If this is 10, from here up to here should be 8. That means this one should be 18. And then finally it decelerated at a rate of 6 meters per second. Decelerating. If a body is decelerating, deceleration is always represented with the graph of a negative gradient. Deceleration on a velocity time graph is represented by a graph of a negative gradient. Is that okay? So that means that a graph of negative gradient will look like this. This is for deceleration, this is for acceleration, this is for deceleration, this is for constant acceleration. Maintaining the velocity constant will mean acceleration is 0. We are combining the graphs we had looked at. This first part, if this is O, if this is A, B, C. In OA, that is acceleration, uniform acceleration. And then in AB, that is 0 acceleration. And then in BC, that is uniform deceleration. And it has been given to us as A equaling to negative. Because the graph here is having a negative gradient. Here the graph here is having a positive gradient. Remember when we are trying to do our sketching of the graph, you'd say this one is a constant gradient but it is a negative. This is a constant gradient but is a positive. So therefore, that means that it is very important always when I draw a graph I put a positive, that means that it was acceleration. If I draw here I put a negative to mean that it was a deceleration. So this is my velocity time graph. Now the issue is we don't know the time which is supposed to be here. We don't know the time which is supposed to be there. So sketch the velocity time graph. It is this one here. It is in meters per second. Time in second. It will be T3 maybe. I can call it T3. I can call it T3. Good. In other words, now here it means from here up to here. T1, T is 10. From here to here, T is 8. And then from here to here is what I don't know. I can call it like that. I can call it like that. And then find the maximum velocity of the body. What is the V? And then I can considering it. OA. Considering OA. Is that it? I would consider now the body moving from O to A. If I'm considering OA, what is the gradient of OA? Grad of line OA will be equal to change in V over change in T. But we said gradient is always acceleration and is equal to 8. So what is change in V? It will be V minus 0. From here up to here is the V. Then it is V minus 0, or you can say V divided by time. The length here is V and here is T. So that means that it is V out of time, but the time here is 10, should be equaling to 8. So that means that V out of 10 equaling to 8, implying that V equaling to 8. Is that okay? Therefore, the maximum velocity is 80 meters per second. Clear? And then you can now say, what is the total distance? Part B. This is part B, Roman 1. This is Roman 2. That is Roman 2. How now do you get the total distance for the whole journey? That is area under the graph. Total distance is equal to area under the graph. Okay? But before we get the area under the graph, we need to know which time is here. Okay? And then I can say, considering a BC, we can say grad BC will be equal to change in V over change in T. And that will be equal to -6. The gradient is a negative. Gradient of this line here, which is acceleration, is -6. So, but what is change in V? The same as this, isn't it? That is the same as a -6 equaling to change in V, which is V, out of change in T, which is T. And then it implies that -6 equaling to V. V is 80 out of T. Is that okay? There is a problem here. Wait. Grad BC is changing that. So that means if a body moves from here up to here, finally here, the change grad BC, the change here would be equal to 0 minus that value, V, out of change in T. Is that okay? So to be equal to -6. And then if we have that, we shall say minus V is -80 out of T equal to -6. And then it will imply that T is -80 out of -6. And then what is T? Get your calculator. You can get your calculator and say what is 80 divided by 6. That is 13.333. That is 13.33, or you can reduce it by 2 to become 40 out of 3. Become 40 out of 3 seconds, that is 13. That is the time taken. Please, if we can review this again, we said that a body accelerated uniformly from rest at a rate of 8 meters per second for 10 seconds and attained the velocity V. If it then maintained the velocity for 8 seconds and finally decelerated at a rate of 6 meters per second. We say that to draw a velocity time graph, you should know how do we draw the part of accelerating. How do we draw the part of decelerating? Fall back on your notes on that part of velocity time graph for acceleration, for deceleration, for zero acceleration, or constant velocity. Those are the parts we are going to look at. So, if the body is accelerated uniformly, that from rest moreover, that means that if you draw something like this, the accelerating, decelerating from rest will mean you begin drawing the graph from here. And because it is accelerating, and you are talking about velocity time graph, okay? You should draw that part as a straight line. Because behind that we say that this is a constant positive gradient and a uniform acceleration. If you check behind there. So that means we draw it like that, and then we said also that the slope of velocity time graph is always acceleration. That means that the slope here is the acceleration given as 8 meters per
And then they said that happened for 10 seconds. And then also they told you that this body maintained that speed. It had a constant velocity. How do we draw a constant velocity for a velocity time graph? A constant velocity is the same as zero acceleration or the same as no acceleration. And that would mean that now draw a line from beginning from where you had stopped horizontally. We call the other side, these are the same as zero acceleration, okay, which is the same as a constant velocity. Is that okay? And then in the next part, they said that the body decelerated. And we said on our velocity time graph, if a body is decelerating, we draw a straight line with a negative gradient. Is that okay? We said it is something like this. You draw that negative gradient. This is the uniform deceleration. It decelerated uniformly. So that means I draw a line like that. And then this will be negative because it has a negative gradient for that. But the time here we don't know. Here they said the constant one was for 80 seconds. But here we don't know the time. Is that okay? And now we said that is our velocity time graph. And then we said that supposing they tell you to find maximum velocity attained. If they tell you to find the maximum velocity attained, you can now say, considering part OA, the gradient of OA is acceleration. Is the same as change in Y over change in X. So you can guide yourself using this. This is V, this is 10, and this is the 8. So that means that gradient is change in Y over change in Y is V. Isn't it? Or you say V minus 0 because it would be the value here, okay? The value here minus the value which is V minus 0. Or you can just say it is V out of 10. Clear? It is V out of 10 because I would say this point here, in terms of coordinate, it is origin 0, 0. This coordinate here is V with 10. And this coordinate here is 10 with 0. So I would say it is now changing this over changing it. Is that okay? But now what is the change here? This is 10, 0. This is 10, 0. I mean 10V. In the X it is 10. Here it is V. Here is 0, 0 origin. Here is 10. Here is 10 with 0. So if I'm looking at the change here, I say V minus 0. Okay? V minus 0 out of the change here also. V minus 0 is as the change in Y over this 10 minus 0. That will give you that. So if I'm to draw that for you, just say the other diagram, you can draw it as this is point O. If it is origin, it will be 0, 0. And now this one here would be now 10, 0. And then this one here will be now 10 with the V. So changing V here will be V minus that. And then the change here will be 10 minus 0. So it is V minus 0 over 10 minus 0 equaling to 8. Equaling to the gradient of this line here. So that means that I can say it is V out of 10 equaling to 8 and V equaling to 80. Clear? And then the same thing that we can now do here. That if I have this here, I can also draw it like this. I can say this point here. Okay?
this point here, I have this point here is V, but I can begin with the coordinate which is here, is 18 with V, and now the coordinate here is 18 with 0 here. On t time we have that, but V is 0. And then here I can have now that can be 18 plus t and a 0. So when I'm looking at the gradient, I can look at the change here, isn't it? V minus 0. Okay, and then I can look at 18. I can look at 18 plus t minus 18, which is equivalent to the t now. So that means that the change here is t, the change here is v, but is equivalent to 6. Is that okay? And we say that if we consider the gradient to be a negative one, we should now say it is now here will be equal to this one minus the value here, which is now 0 minus v out of change in t. Or if you can't do that, you can also do it in this format here. And now you say this is the same as, because you're calculating the gradient, you can say this is the same as now v out of t equaling to 6, because you have noted the negative. So you can now say my v here is 80 out of t equaling to 6, and then t equaling to 80 out of 6, which is the 13 point something that we were getting here. 80 divided by 6, which is 13.333. And then after knowing this time here as 40 out of 3, 80 out of 6 is the same as the 40 out of 3, we can now calculate the total distance by calculating the area here. Where can we calculate the area? I can calculate the area from here. I can calculate the area by saying that this is a triangle. This is a trapezium. Area will be equal to a half h into a plus a, where now this distance here is my a, this distance here is my b, and this height here is my h. That is what I can tell you. So I can now say my area is a half times the height is the velocity, okay, which is 80. A is the distance from here up to here, that is 8, plus the distance here plus here, that is 18 plus 40 out of 3, or 13.33. What is that area? Okay, and that means that if I press, it will be plus 18 plus 8 will give me this times 80 divide by 2. So that means I have something like 1573.32 meters, and this is the area. That is the area, because we said that the total distance is the area under the graph. But here our graph, here the area is the trapezium. That means that use the formula for the area of trapezium to calculate our total distance covered. We are doing all this on a fact that the gradient of a velocity time graph is acceleration, and the total distance under the velocity time graph, the total area under the velocity time graph is the distance. So if they ask you to find anything, I can use the gradient method to get acceleration. Or if the acceleration is given, I can use the gradient method. I can use the gradient method to get any other value. Like take an example here, we are given this value here. So the gradient of this is 8. And you should be knowing how to calculate gradient. Isn't it? You should be knowing how to calculate gradient. Changing this over changing that. If this change here is V, if this change here is V, and then this change is T, I will say it is V out of T, equaling to that. Okay? V out of T equaling to the gradient, which is acceleration, to get V. And now here, you can also say that by the fact that the velocity is reducing, I would say here that by the fact that the velocity is increasing here, I would say it is the final velocity minus the initial. But the final is 0, the initial is at this point here, which is V. Out of the time here was T, is equaling to, in that case, I can say it is -6. And then you can say negative V is 80 out of time equal to -6. That still takes you to the answer. Or you use this idea here, that if you don't mind of the change, how the velocity is changing, you can just say change in velocity over change in time equaling to this. But it is very important for you to master that if the velocity is changing, a bigger velocity is here. Is that okay? The change in velocity, the final velocity is here. That's what I mean. That the final velocity is here. This one is the initial. Then, and you know that when you're looking at a gradient, you look at final minus initial, divide by also this one final minus initial. So if the final here is going to be 0, I'll say it is 0 minus the one which is here, V, divided by the time here, would be also T minus what is there. And that was giving us 18 plus T minus 18. That is still a value of T should be equal to -6. And from there, you can get your time. Is that okay? So, after getting your time, you know this time here. To calculate this one here, we shall say area under the graph is the displacement. I have HA plus B. We say A will be this and B will be that. And then I will say I have the height. The height will be equal to the velocity, which is 80. And then the A will be this one, which is the 8. Okay? And then plus the base here will be a 10. It will be 10 plus 8. And then plus this. That means that here we have made some simple mistake here. So that means that the base here was supposed to be 10 plus 8, and then plus this one here. We are supposed to get this as our B. This plus this plus this, which is 10 plus 8 plus the T. And the T was the 13.333. So, if you press that quickly, you will get now 18 plus 13.33. What are we getting? Sorry, 18 plus 13.33. You add that. And then you say times 80. And then divide by 2. That is this. This answer, we have blundered it. We have blundered it. This is supposed to be 1253. 1253.332 meters. That is the correct answer, okay? Because we are supposed to take the base as the base of the trapezium, which is 10 plus 8 plus what we already calculated there. So, having looked at that example,
let's first take some short break and then we meet for the next part of our mechanics. Thank you.